if you go too light,
Yeah.
like it's always offshore. Like even when it's onshore in really big waves,
It's always offshore.
it's still offshore.
Yeah.
I mean,
All
it
the
can
wind
be
is being
onshore,
sucked
and,
up
and
the
as that
face.
wall of water, that mountain of water is moving forward, air is rushing up the face.
Yeah.
And so you actually, when you surf big waves, you actually want it to be onshore. It kind of helps you get over the edge. So the wind actually creates an issue when the board's too light. So even though the boards are EPS and epoxy, they're actually not light.
Really?
Yeah.
Are you doing anything to dampen the boards? Like, what are you doing to keep them damp and resist chatter? Because you don't want something too flexible, but you don't want it too stiff.
Okay. So the entire board needs to be stiff as far as if I put a few bricks on the ground
Yeah.
and I put the board on those bricks at the nose and tail and I stood on it, I don't want the board to be flexing like a trampoline.
Pushing water, basically.
Okay,
that way.
it needs to be stiffer. Like as you go down a big wave, right? If you're in a small wave, waist high or something, you take off. When you do a bottom turn, you pretty much are loading approximately your body weight into the bottom turn. If you really compress and then extend your legs, you might be adding another 20% of your body weight. But if you're screaming down the face of a huge wave, I've dropped into waves where when I've hit the bottom, the G-force has been so strong that my legs physically didn't have the strength to hold my body up. All of a sudden, I'm doing like a 200-kilo squat. I've just got all this weight on my shoulders and I can't even hold my own body weight up. So, literally you can fly down the face of a wave and if you're 100 kilo and all of a sudden you're getting like 2 Gs or 2.5 Gs in the bottom turn, you got 250 kilo loading on that board. So the board actually needs to be stiffer. You still actually do want it to flex, but you want it to flex under higher loads. Yeah. So the entire board does need to be stiffer to deal with the G-force of the acceleration through the turn and the load coming down on the board. But the other thing that's really unique to our boards, which is this cross-section here in front of you.
Okay.
And I'll maybe just let you pick it up. Okay. Give the deck a squeeze. And just look at what happens to the core.
Yeah.
Okay, now give the bottom a squeeze. Can you see it like denting right in and then springing back?
Yeah.
Okay, so what that does is that's a shock absorber.
Right.
All right?
You had mentioned this in an interview where you were talking about like air mats.
Yes.
And how
Correct.
air mats is similar philosophy.
An air mattress is so fast across choppy conditions. And so what happens is the bottom of the board is like morphing and absorbing the chop. Because what you don't want is you don't want those chops transferring through the board to the rider. Otherwise, it's going to be a bumpy ride.
Shock absorbers.
Shock absorbers. So the whole bottom offers like a cushioned ride. It absorbs the shock and it absorbs the bumps. And that's the reason Sebastian can fly across those waves. And you look at footage of Sebastian surfing and you look at footage of the other guys. The other guys are bouncing around and they're just hanging on for life. They're like on these death machines. And you see him and he's just flying down the face and there's this clean, crisp wake coming off his rail. And he's not bouncing around at all.
That's fascinating. I never would even thought about it like that. I doubt a lot of shapers are even thinking of it like that way. That's crazy.
Yeah.
Fuck.
And so that's part of like getting the materials and engineering it in such a way that the deck is stiff, the rider can transfer his load, he can transfer his weight and his energy over the entire board. The parabolic rail, like your stringer, is on the rail. Okay, so the stringer in a normal board, like if you think about what a stringer does, back at one point in the 50s, 60s, boards were made stringerless.
Yeah.
So it was just like a Clark foam blank with no stringer.
Yeah.
And I remember asking this old board builder, Lenny Dibben, I said, Len, so did you put stringers in boards to make them stronger? And his reply was, fuck no, they just didn't go. I mean, it was just like this floppy piece of rubber. So what the stringer did, but he also said that when they made stringerless boards, they didn't have a stringer in them. They just used an extra layer of glass top and bottom. So the boards were actually stronger. And when they got hit by a wave, they flexed more and sprung back. So the boards didn't break as much, but they were floppy and had this weird springy reverberation. So what the stringer did was the stringer allowed the board to keep its shape, both in the production process and when you surfed it. When you put it into a turn, it kind of twanged back into position and gave it a little bit more life. So what the wood does is the wood is the part of the board that makes the board spring back to its original shape with a little bit more liveliness.
Yeah.
And so if you think about like a normal PU board, like what the pros are riding, it's got a stringer down the middle. Okay, so the stringer line, it's connected to the bottom and to the top. You've got the glass top and bottom. So the stringer's going to be stiff. The rail line is actually going to flex independently of the stringer.
Yeah.
Okay, so envision this. You've got a flat bottom board. You're going into a bottom turn. As you load your weight into the board, that inside rail that's engaged with the water, it's literally being forced in that direction. It's twisting off.
Torsional flex.
Right.
Yeah.
So what will happen is a board that's actually a flat bottom, as you load it through a turn, it's actually becoming a rolled or V bottom through the tail. Okay? And a roll or a V bottom is going to be a little slower. So by adding concave to a PU board, what you're doing
stiffening
is you're allowing for the way the material flexes so that when you load through the bottom turn, it becomes a more favourable flat bottom, faster on the inside rail, and you also get a change of water direction on the outside rail, lifting the board up onto the rail. So the stringer acts as this kind of stiffer, rigid thing, but when the board does flex, it'll spring it back into position. Okay, so just kind of like emphasising the point about the importance of a stringer in a conventional board.
Yeah.
But the spring back is coming from the centre line. But when you're on rail, you got foam and fiberglass in the water. So you're only relying on foam and fiberglass for the spring back out of the turns. So by putting the stringer in the rail line, you're now getting the spring back from the rail line, because you know already that the stringer is important for making the board twang back into position. By putting that in the rail's actually engaged. It's below the water line, so the spring back is coming from not something that's out in the air, but deeply engaged in the water. So a lot of people say that when they bottom turn one of our boards, it's like a slingshot.
Yeah.
Yeah. Or it's like a catapult. Yeah.
Fuck. So when I hear this then, and then like I've seen like certain constructions like Darren Hanley did and Surf Tech does, where they have the EPS stiffer foam, more higher density foam in the middle, but they're doing poly rails of the foam. That doesn't seem like that would work then.
Honestly, look, I had one shaper tell me once, he doesn't use wood because it's the one element he can't control.
Yeah.
And he was actually right. Like the thing with timber is it's a difficult medium to work with, right? Like you look at foam, it comes in a certain density, and if you say, I want 40 kilo cubic meter, you get 40 kilo cubic meter.
Yeah.
Resin, it has a weight. Glass, it has a weight. I mean, and it has a density and it has a certain property. But wood, I mean, it just varies from tree to tree.
Yeah.
I mean, you get a density range, but, when you bend a bit of wood, it's so lively when it springs back. But one bit of wood can be better than another. And I remember like years back when Morris was building boards for Taj.
Yeah.
Taj would get like 150 new boards a year, right? So he's basically getting 3 new boards a week. He would get batches of them. He would get 5 and 6 at a time. He'd go and ride them all. 3 or 4 would just go straight back. No, don't like it, don't like it, don't like it. Yeah, this one, okay. This one, yeah, that's a keeper. And so in the end, out of 150 boards a year, like 20 probably turned into keepers. But what was the difference? The only difference between all those boards was the stringer.
Wow.
Everything else was identical. And so that kind of tells you that there's variability in timber. And so when this other shaper said to me, I don't use timber because I can't, it's one element I can't control. Mm-hmm. There's truth in that, but at the same time, it's where the magic is. Mm-hmm. Because when you get that magic bit of wood, it's like the Stradivarius. Mm-hmm. Man, there's nothing better. You can't make any other composite material perform as good as that, as far as the way it flexes and it springs back, just almost like in time with like the timing of human movements or whatever.
Yeah.
Look, I don't know, maybe someone else has got some other better scientific explanation, but essentially timber just has this smooth ride, and it's the way it like loads and unloads and springs back and just adds another dimension to how a board performs. And the more wood you can put in a board, okay, that's not true. Yeah, look, it's a balance. Like if you look at what we have an inch of stringer material. We have half an inch each rail. Yeah. An average PU maybe has an eighth of an inch down the middle. But the fact we use that much, it's because the density of the timber is lighter. Mm-hmm. Obviously if we were using like a birch or a cedar or a jarrah or something else, we'd have to use less of it.
Yeah.
So it's relative to the density and the weight of the timber as to how much you should use. And all different constructions, like there's no arbitrary one shape.
Yeah.
That you say this is the best board money can buy or this is the best performance shape ever. Every single shape is relevant to its construction process and its materials, because
and its rider.
Yeah, well, the rider has relevance, but each board and what it's constructed of will give it like performance characteristics where you may need to change the shape for some processes. Like if you look at, if you were just using wood, just a piece of hardwood, what would be the ideal shape?
Probably be on a Alaya or something.
Got it. Spot on.
Yeah.
Okay. So if you think about the ancient Hawaiians, that was the technology they had, and they got to a point where that was the best shape they came up with in that technology.
And you couldn't come up with a better shape even today.
No,
really.
that's it.
I mean, we've gone back to riding
tried and tested.
Yeah.
So I feel it's the same with surfboards now. When new technology comes out, different shapes start to become more relevant to those technologies. And so when people look at a shape, oh, that's not going to work. Well, fuck, they got no fucking idea if they're not taking the construction, the materials, and the way it's put together into consideration.
All right. So last question. 'Cause we've had a marathon here, and this has been awesome. And to be honest, there's been so much wood talk, I've really had to hold back from making any sort of really sexualized jokes, I guess. What was the last board you've been riding? What are you riding right now? What's like, what are you really into?
The last board.
Or what are you into right now in terms of boards?
Me personally, I got three boards that I kind of like vary between. So I've got just one. I actually went back to a board I was riding from maybe 95 to 2008. Damn. It was just kind of tried and trusted favourite. It was just in fact, it was probably earlier. It was maybe 93 or something. But anyway, I rode this one board for close to 15 years, or this one style of board, certain outline, just a sort of a high performance short board, a little bit of a bump flyer, round tail, a lot of rocker. But now what I've gone and done is I've just gone and scaled it up for my, I'm like, I drink beer, right? Put a little bit of weight on. Went off on a sort of a business expansion project, and I wasn't getting in the water as much, and so look, I'm riding one good high performance board that I had for a long time. I went down this road of like shorter, fatter, wider, thicker, and they were just fucking boats. I hated them, so I went back to this skinny little wafer that I had, but I just scaled it up for my current size. So I'm riding a 7 foot plus like short board, performance
Nice.
board. But I need good waves for that. It's got to be overhead and the
Yeah.
bottom's got to be dropping out of it. I got another 9 footer performance board I like to ride.